of you does have some layout experience who was working with Cadence? So Thomas, I'm Matthias, by the way. So who of you, who has some layout experience with Cadence maybe, or other tools? And who a little okay. And who of you already coded Skill? No one? A little? Okay. Because this is going to be mainly, so first thing we want to do is, or I want to show is first how to draw in KLayout, which is probably different, but on the other hand, similar to what you do in Cadence. The second thing we are going into is how you actually generate layout using scripts. Because this is eventually what we are going to do. Finally, so the whole analog generation thing is about generating layout and not drawing it. And I mean, you can do with Skill in Cadence. Skill is the automation language you use in Cadence. So instead of drawing something, you use commands to generate layout. And KLayout can do the same. The difference between KLayout and Skill or Cadence is that KLayout is focusing on layout, and it doesn't have schematic built in as of now. And second, it's an open source tool, so everyone can use it. And it's also available in different flavors. So it's not only a full framework like Cadence is. You can also use it as a single Python library. So you can without the overhead of a user or of a full-blown application, you can start producing layout using eventually the same classes and methods and objects you do inside the application. So, I mean, just a few words about how this, or what this program, how it came into life. Actually, I'm currently employed at Infineon. This program is, however, not related to Infineon. It's basically my private project, so I'm here in a twofold role. And but still, Infineon uses this program a lot in many respects. So of course, yeah, viewing layouts mainly because that is how it started. It started as a viewer for layout, and currently, I think I can. Well, there's a huge number of users actually at Infineon using this tool, mainly because it's available on Windows as well. So they don't have to enter the Linux environment just to view GDS files. And everyone who deals with GDS files, layout files, basically, in the course of designing something or generating layout for certain purposes, they use this tool. My task at Infineon is currently enabling technology development on the last mile, so close to mask making, which means that we are using Cadence, of course, but we are also using KLayout, for example, to do very basic structures like litho alignment structures, things like that, stuff you don't need Cadence for. And in the environment I'm working with, we have a kind of hen and egg problem, because when we start doing a technology development, we usually don't have a PDK. And on the other hand, we have to design test structures for enabling this technology development, like certain devices they want to try. And of course, when you try a device, you don't have a final picture and you don't have a PDK. And this is why we need tools which are able to work without a fully evolved PDK. And that is why we use every tool that is available, including KLayout if necessary. Right? And the outcome of these activities is typically tape out, where you can, where they have these test devices on. Then they start evaluating them. They go through iterations. They start to do variations. Look what's working nicely, what isn't. Kick off the ones that kick out the devices which don't work. Optimize the ones which do work, and finally you get something like a PDK. But that's far after I did the first takeout for them. And so that's why my focus is mainly on, let's say, I would say, let's say, experimental design, rather than what you do here, working with a ready-made and available, tested, verified PDK. So I don't go through these details. I mean, we are here to do hands-on, and I don't want to give a presentation about all the details. As I said, KLayout started initially as a viewer, so that's still the main strength. When I did this, actually what I had was very huge files, because we are close to mask, and when it comes close to mask, file sizes actually explode, because you start doing things like dummy tiling, so you create a lot of dummy features on the mask, which are supposed to support manufacturing, like density, leveling, things like that. So you get very, very huge files. So we are talking about 10 gigabytes, and today even advanced nodes, they are speaking even of terabyte of data for a single mask. And the strength is definitely to be able to handle large files. You cannot load a 10 gigabyte layout into Cadence just to view it. That simply doesn't work, or it's rather slow. And KLayout was used as a viewer for these kind of files. And it's quite fast and memory efficient, if you want. And what my personal the best feature I like most is that KLayout doesn't optimize away features when you look at it on top level. So which is very important, because if you look for a single shape on the whole mask and you want to see where it is, and it's very difficult, some tools, they just optimize away small parts when you're on top level of your design. And I want to see a specific shape, which is maybe an XOR difference, so the delta between two masks. And I want to see this one, and KLayout doesn't optimize it away. So I have a chance to really see that, even if I'm on the full mask level. And that's something that is very useful for me personally, because that you're basically looking for a needle in a haystack. You want to see a specific shape. And well, that's my personal favorite feature, but well, I don't want to advertise too much here. You will find others who do that. I mean, the limitations, please don't expect a full design system here. Yeah, it's focused on layout mainly, but many people are using the combination of Xscheme and KLayout, so you get something like well, it's not a full-blown virtuoso environment, but you can start doing things which are kind of similar. I don't know, maybe did you?
Yeah, I mean, that's
something of that
kind.
Okay, very good. Yeah. And honestly, I never tried myself Xscheme, but I heard of people who do that. I mean, now including you. So, well, I mean, it's not tightly integrated like Virtuoso XL is, so you don't have back annotation of nets and so on, of course. But, well, we are not at the end of the development here. Yeah. So I hope there's some evolution happening. Okay, well, that's just a main picture of how it looks like. And with that, I actually would like to start entering the practical session. I mean, I'm not trying to give you a lecture. Okay, I think it's very good. I'm not trying to give you a lecture here, but I would like you to experiment and try out, just like to learn how to use it, and then you can start playing with the tool yourself. So first part of my presentation is about, let's say, using the tool in a practical or in a manual fashion. So how do you start it? How do you draw something you want to draw? And well, the first thing, this is a mission you have already accomplished. I think you need to get KLayout. I was prepared to go through that process with you, but who doesn't have it as of now? So you all got it installed somewhere, either privately or inside SDF? SDF, okay. I mean, you can use it inside SDF or locally on your computer. For us, it doesn't make a real difference here. The version inside SDF is, let's say, not fully deployed because it lacks the whole Ruby support. So KLayout has two ways of scripting, so two languages built in. One is Python, you all know, I hope. or who doesn't have experience coding in Python? Everyone has, very good. The second language that is used inside KLayout is Ruby, which is, well, it's a similar language to Python. It has some differences. The reason I chose it was that initially Python wasn't evolved far enough. I thought it wasn't mature enough, and so I used Ruby. Now we have two languages built in, but Ruby is the basis of a couple of features, including DRC and LVS. So as the SDF environment doesn't offer Ruby, we cannot do DRC and LVS as of now inside SDF. But we can do all the exercises I'm going through with you, because they are only Python. There are a couple of other, okay, I will actually skip that because you did this already. There are some other ways to utilize KLayout or the Python layout generation path inside KLayout. One is, a very easy option is to use the Python module, which is available. You can download the Python module from PyPy, which is the Python module repository. And it offers some of the features we are going to use. So you can do the same things I'm going to show you with this Python module. You don't need the application, you just need to install this Python module. And you can do so, for example, in Conda, you can do so in Linux, you can do so on Windows. I can use this Python module inside PyCharm, inside Jupyter notebooks, and whatever. And if you look at projects like GDS Factory, for example, they are employing this Python modules as their internal engine. And they have a very nice integration into Jupyter. So it's better integrated than the pure Python module. So you can, when you draw something, you get a graphical display of the results. What I'm going to show you is a bit of a workaround. You also have some ways of playing and seeing the results graphically. Yeah, we will see. Okay, let's get started. So first thing is, let's draw a box. That's very simple. So the way you do it, or first before you do it, you need to know two things. Or one thing eventually. KLayout has two modes. One is a plain viewer mode, where you can only look at layouts, and the other mode is an editor mode. So when you run KLayout, you will see that it starts up. And here, for example, I see, everyone I see here has viewer mode. Okay. That's a problem, because in viewer mode, you cannot actually start drawing things. So the way you start it is, if you're on the command line, you use KLayout-E. To edit, okay, that's fine. So you did already. If you use it privately on Windows, it has a lot more options, you see, or a lot more tools available. If you use it on Windows, then inside the start menu, you will find an entry called KLayout Editor, and you just use that one. You can also configure it to use a specific mode for default. And the way you do it, okay, the way you do it, I'll show you. So if you go to Setup, here to this page, can you read this? There's one checkbox here. If you, so I used File Setup. Sorry, this was too fast maybe. File Setup. And then there's a page application editing mode. If you check this checkbox here, KLayout will start by default in editing mode. And that is what I recommend to do, because then when you double click on a GDS file, for example, it will start in edit mode. If you don't like edit mode because you don't want to damage your layouts or for whatever reason, then don't check this. There's one reason why there are two different modes. In viewer mode, KLayout can do a lot of optimizations inside the data structures, so it takes much less memory if you load huge files. So you have to deal with very, very large files, and specifically OASIS, which is the successor format of GDS. Then I would recommend using viewer mode if you just want to view these files. It's much faster, it takes much less memory usually. But if you are, I mean, we're talking about 10G and more, these kind of file sizes. Usually layouts you deal with are much smaller, you can use edit mode always. Okay, so this is how edit mode looks like. And I mean, you can tell that it's edit mode because you have a lot more tools available above here. And these are the tools you use for drawing things. First thing we need to do when we start drawing, the first thing we need a document. A document in KLayout is called a layout. A layout is basically what you see when you read a cell in Virtuoso, what is called a cell view in Virtuoso. And to create a layout, you use, of course, file new layout. And you're getting asked a few things. Basically, you can just click OK, but it's a bit easier to start with, let's say, a few basics. And what I will do here is I will enter a 1 in this initial layer field. The background is KLayout doesn't, or by default, does not have a technology file like you're used with Cadence. So it doesn't have a setup of all layers you are going to draw. And basically nothing is configured. We will do it ourselves here by adding one layer first. So this layers in GDS have numbers. They don't have names. That's something special about GDS. In GDS, layers are numbered from 0 to, previously it was 255. Today you can number it to 60,000 something. And in GDS, a layer has a number and a data type number. A data type is typically used for purposes. So like if you have a metal layer and you have a purpose which is drawing, then it's maybe data type 0. And you might also have a purpose which is for labels. And then it might have a purpose number 1 or data type number 1. And in KLayout, you either just enter the layer name here, layer number here, which means it gets data type 0. But you can also enter a specific data type here, like 10, and it's separated with a slash. So 1/10 means layer 1, data type 10. This is pretty basic, so we will see later how we can simplify this. But just for getting started, we have to define the layers ourselves. I will just create one layer. I could also create 3 layers by using a comma to separate them. Let's just try. So, okay, I forgot the comma, I guess. Something didn't work. What did I do? Okay, now I've got the comma. So now we have 3 layers here. which are 1, 2, 3. I didn't specify a data type, so they have data type 0. And yeah, actually we are set up.
Yes, Matthias, I just wanted to ask you why this is like happening with with the present. Can you see?
Yes, I don't know. So it's not happening on my screen.
Okay, so can the bootcamp participants can log out of the call? I think maybe Sal Guest Network has its own limitations.
Okay.
And you all use it to access the servers. You're all using it to access the bootcamp call. So maybe that's the. I mean, I have no idea.
Yeah.
That is like the.
Or maybe it's just a screen.
No, I see it also.
Oh, okay.
That's why I came to see.
Yeah, it's on the recording.
Yeah, on the recording,
Okay.
it can be quite kind of annoying. So if it's possible, just close the calls. I think, Ryan, you cannot because you're sharing. Only you can stay.
Yeah, that's a funny effect. So do you see it on your screen?
Yes.
Okay. Does it get better?
Share and share problem.
I don't think that is your problem with this like monitor. I think it is with something with maybe Matthias connectivity.
Yeah, it might be the same. Are you in viewing? Are you guys in viewing?
It didn't stop recording.
No.
Yes, I am in the
It might be.
Yeah, let's try again. When you kind of just log out of the cell guest, and maybe you only want to share the screen. You
I
log
hope it's
in
not related to the
bootcamp.
Teams application.
Hmm?
I hope it's not related to Teams application.
I don't know.
But it's not on my screen. So.
It's not on your screen,
No.
so
It looks like it's looking through the application. If you have the browser behind, it flashes it.
Sure, then maybe I can close some.
Let's try a computer.
Yeah, let's close a few things here. No.
But you don't see it on your screen.
I don't see it there.
The share.
Oops.
In the,
So
I mean,
there is another way we'll continue, but it's a bit annoying.
It's yes, but okay. I mean, eventually it's just click a. But that's weird. It looks to be on my computer, but it's the Teams application.
You know what could be you sharing the whole screen, not specific window, and that's why it maybe it is having a problem to process it. I don't know. I mean, this is just wild.
Yeah.
So what? But because you're kind of going between these two things, we cannot.
So if I reduce the number of windows, maybe. But I would like to switch between the windows. So
I know. Just go ahead and we try. We did not succeed. Hopefully, it is like visible. It's not too annoying for people who are following.
Okay. I mean, now it happens somewhere in the.
Yes,
on
something.
frame. Maybe it's better
better
this way.
Yeah.
Okay.
Yeah, keep going.
No. Okay, so we have set up this layout now, and we are ready to basically do things with that. And as I said, the first thing is we are going to draw a rectangle, and to do so you select here one of the layers. You choose the tool you want to have, and then click once, click a second time, and you have a rectangle. It's not drag. So often you see tools which where you drag the rectangle, like in PowerPoint or somewhere else. So in these tools, you click once, then you drag, and then you release them once. In KLayout, it's like clicking once, clicking the second time, and then you have the rectangle. And the reason for doing that is you often find that while you drag, you will need to zoom. So you zoom, for example, with the mouse wheel, and it's very difficult to zoom while you have to keep the mouse button pressed. So like when you go to a certain position, it might be like far away, like here, right? And now I can still zoom in. I can actually place my second point here. And that is why it uses this two-click approach. And that's pretty fundamental, so you cannot turn it off. You always use one click for one point and the second for the second point. Then when you want to leave this edit mode, you just hit escape. So you just click where. If you want to leave it, just hit escape, which will also bring you back to select mode, which is the default mode. Then check box again to re-enter. zooming happens with the mouse wheel. You can also use the right mouse button to drag a rectangle where you want to zoom in. When you drag the rectangle in that way, so like top right, it will zoom to the whole layout. So it will bring the whole layout into view. When you drag it from bottom to top right, it will zoom into the selected area. And if you zoom in that direction, so like left top, left up, it will zoom out. Yeah. Okay, so, but personally, I prefer the mouse wheel. It's much more convenient. You can also press the middle mouse button, which in my case is the mouse wheel, and then I can drag the window around. Yeah. So like here. You see one thing here. You see that I have enabled the axis here. I think you don't see the axis yourself, so you then don't see where the 0 location is. I would advise you to do so. It's by using setup, and then we go to background, and then you see this selection here, this setting, and I have set it to lines, which means the axis will be drawn as lines. Yeah. And that is pretty convenient if you want to, if you're working with coordinates, so you see precisely where is the 0 coordinate. By default, it's not shown. Don't ask me why. I would advise you to enable it so it's easier for you to locate yourself in the coordinate space. And well, we can go ahead. So we can add, I can also select different layers. I can draw different rectangles. It's a bit hard to see because it has the same colors. That's why I'm going to show you, or a similar color. That's why I'm going to show you what you can do in terms of coloring. So there are a couple of options. First of all, I can set the color of a specific layer. Like let's make this one green and this one red. I can also set the fill style. So now it's solid filled. Now it's, there are different pattern I can use for filling. I can even design my own pattern here. So there is a button which says custom pattern. If I click that, I enter a pattern editor. I mean, that's just for playing around, so it's a nice fancy feature. I don't think you will use it quite often, except if you prepare layer setups yourself. I can generate a new one. I can, this button inverts everything. So I can basically start, I should give it a dimension. Like that, and I can start setting pixels here, and I can create some fancy fill feature. And now if I use the more button here below, you will see this fill feature now is available here, and I can use it to style my layer with that particular fill feature. One remark for those who are using high resolution screens, they might not really see it because actually the pixels are so small on a high resolution screen that this fill pattern kind of gets smeared. So you have either to use large fill patterns which look ugly on low resolution screens, or the application had to take care and scale them up properly. I have not implemented this so far, so I don't own high resolution hardware as of now. And honestly, my eyes are so bad due to the age, I don't really benefit from high resolution hardware. So you want to suggest having eyes laser cured?
No, just a question. This is only something static. No, that doesn't affect the layout or anything.
Yeah, this is just styling, right?
Styling.
Yeah. So you see, when you enter a typical Virtuoso environment, someone has prepared all the styling for you. But in Virtuoso, it's the text file, it's the display file, it's the layer mapping. All of that together is compiled into a PDK for Virtuoso, and someone else has done this work for you. And usually these people, they consider a lot of things like visibility of layers, how do they overlay, what layers do you typically overlay versus each other. So usually you're not concerned with this, and it's a kind of art to design such a setup properly. I'm showing you this because it's well, let's say grassroots, what we're doing, starting from scratch. You can also, later I will show you how to use layer properties files. And if you, for example, use a Skywater PDK, it comes with a layer properties file, and you don't have to do it yourself. Yeah. So, but it's like fun styling that yourself, so you can apply whatever you wanted to ever have in terms of making it nicer. I mean, while we do this, I can show you a little more. What is available. So, for example, here there are two color fields. One of them is only affecting the boundary. So now let's take a different one. So like here, now it's a bit hard to see. I have given it now a boundary color which is blue and a fill color which is red. Let's go back to a different style which is easier to see. Then I can set the line width. So this is 3 pixels, for example. Now it's a bit thicker. Also on high resolution screens, it will be 3 physical pictures, which are pixels, which are quite small. So it's probably doesn't make a lot of difference for you. What is also important is you can make the shapes, specifically rectangles, being cross-marked. That means a cross is drawn. That is often used for via layers, where you have typically single rectangles. And I can specify the layer as marked. It's a bit difficult to see. You see now it draws a small cross here, and that is pretty convenient if you zoom out, because the cross is not scaled when you zoom. Yeah? And that is a way of finding very small shapes which are somewhere in your layout. So if you have a single shape somewhere and you make it marked, then this layer shows up quickly. So it shows up regardless of the zoom level you are in. Well, and you can also give it a line style. So the line is like dashed, for example, here. It's very difficult to see on that screen. I hope it's easier to see on when you share. Or when you look at the shared screen. So this line now is kind of dashed style. But I assume this is interpolating, so kind of smears this dash. Well, what else can I show you? There's one thing you will notice: the background is white. In Cadence, it's typically black. So, but you can configure that if you want. I mean, if you prefer background, and specifically as most of the layer setups you will find are maybe taken from Cadence, so they work better with a dark background. And in order to configure the background, you go to File Setup, then you use this Display Background page, and the background color you can set here. So I have picked black. I mean, some people like to have their background red, which is ugly, but if you want to have it red, then or some other color. But I think there's only white and black. And then what is called the decoration. These are the grid lines and everything. And what I usually do is I set it to a gray level, which is also quite dark. And if you press OK, then your screen will look like that. Okay, now it was too dark. On my screen, it looks pretty nice. On that screen, you hardly see these grid lines and things like that. But this is actually my preferred setting, but well. So is it okay to keep it, or should we go back to white? What do you think?
Yeah.
Like, okay, yeah. Then let's maybe I change the grid line color a bit to something brighter.
Yes.
Okay. Yeah. Well, at least it's visible now. Speaking of grid lines, there's also one thing quite important. Typically, you prefer having grids, which means the points of your shapes will snap to a certain integer multiples of a given basic grid. And if you work with, let's say, like 130 nanometer, the grid is typically 10 nanometer. So you can ask KLayout to specify a grid for you. So there are two ways actually. There's one grid, a global one, but you can also have a set of grids you want to use and you want to choose from. And this is one I have created for myself. So I have entered 10 nanometer, 5 nanometer, 1 nanometer. By the way, all numbers are in micrometer units in KLayout. So this is 10 nanometer, 5 nanometer, 1 nanometer. I mean, we can also add some others like 1 and 0, 1. This is a comma in between. I hope it's okay. One is missing.
I'm sorry, but
yeah.
What does this mean? The default grids are the sizes in the.
Okay, I'll show you immediately. So if I confirm this, I see here in the view menu, I have a grid menu, and I can select here. And for example, if I select 1 micrometer, let's see what happens. So first of all, these grid lines, so these grid markers, it's a bit difficult to see, but here you see some points, and you also see my font. Did I have a question?
No, I see
okay. Okay, and now you see this cross, which is displayed here. It snaps to this grid, which is 1 micrometer. Yeah, you see this distance here below is 2 micrometer, as it says. And now if I draw a box, the corners of the box will always snap to this grid. Yeah. And I can switch the grid inside this view menu. Like when I go to smaller, then I can draw boxes on a smaller grid. Okay. And I'm showing you these features. There's one more thing I wanted to show you. Once you have drawn a box or something, and you want to shift it to a different layer, this works by selecting it. So you click on this.
Dear Matthias, I'm sorry. Can you maximize the screen? I mean, window. It will show better.
Okay.
Sorry. This is better. Thank you.
Very good. Thanks. So before I've drawn 2 boxes, this one and this one. And when I want to change a layer, you basically select the thing you want to change the layer for. You select a new layer here in the layer window, and then you go to Edit, Selection, Change Layer. And this will change the layer of the selected objects. Okay, I'm trying not to explain too much because we have a few more topics here. You will notice in Cadence, it's quite usually to have key shortcuts for all these features. In KLayout, you can also install your own key shortcuts. by default, there are few ones set, but there's also a setup function and available for this, and it says customize menu. And for example, if you want to have this change layer function change to a menu or to a bound to a key, then it is, I need to search, I don't know where it is. So change layer, this is the one, yeah. And I can give it, what's your favorite key binding for change layer? I think it's C. I don't remember, to be honest, what I'm using in Virtuoso. Maybe it's C. So like, let's give it a C. So you enter C here. If you want to give it Shift C, then you write Shift plus C to make it bound to Shift and C. Let's try. So now again, I select this thing. I want to change it to this layer 3. Let's try Shift C. So you see now change to layer 3. So that's also kind of art. People spend a lot of time into setting up key bindings which are easy to use, fast to use. I think in Virtuoso there is a kind of convention what to bind to which key. Q, for example, is always to show the property dialog, things like that. So you can basically also develop your own key bindings here. I think there are customizations like people giving or delivering PDKs for KLayout, and those come with key bindings which are pre-configured, which are, let's say, should establish a common environment for everyone. Okay, that's a lot. I have been talking about boxes. Are there any questions from your side? Okay, so you learned to draw a box, but you also learned how to style layers, you learned how to zoom, you learned how to change key bindings. And that's already a lot for the first part or first mission here. Let me go back to the slides. Here. Okay. Oh, it did reset. Okay. Yeah, that's what I explained to you before. GDS has layers. Layers are numbers in GDS. GDS also comes with cells. I haven't touched this yet. I will do so later. We have created one cell. You probably didn't notice, but it's one cell we have already there in our example. And well, layers come in numbers, cells come in names. I found actually a nice blog below which explains the history of GDS. So, I mean, who actually who knows the term GDS file, basically? Yeah, GDS file. I mean, GDS file, you hardly come in touch with that if you're using Virtuoso. But GDS is, let's say, it's a format for mask layout, which was made in '78, as you see. It's still used widely. GDS actually wasn't a file format, but it was hardware. It was a system. It was some mainframe computer that was sold for the purpose of doing IC layout. And this company who did so, it went bankrupt in '88 or something like that, but the format still persists. And it's still used almost everywhere. So there's a successor format, which is called Oasis, which is supposed to cover, let's say, or to be more efficient in terms of file size or compactness, but still GDS is the de facto standard. And whenever you do a layout or some chip design, the final step is to stream out, they call it, stream out your design into GDS. And GDS is the thing you give the mask shop to produce the physical masks for your design. And so what we do here is basically we're working directly with GDS. So in Virtuoso, you work on an intermediate database, which is typically open access today. In KLayout, you directly work with GDS. So there's no stream out in that sense. You just give your layout file to the mask maker. If you dare to, if you're sure it is done properly or verified it, then you would send it to the mask maker and then he would create the masks. Usually you don't directly send it to the mask maker, but to the person doing the MPW for you or some intermediate agency. But basically GDS is a file for mask layouts. And the nice thing about KLayout is that you can directly edit, view, edit, and modify GDS files. This blog also has some nice explanation where we talk about stream out and what is a tape out. So what's the history behind tape out? I don't know whether you have been involved in tape outs yourself. I didn't. So tape out is actually, I mean, it's the point when you hand over your layout to the mask shop or to the agency who does the MPWs for you. And it's a bit of a, let's say, scary process because after you did so, there's no way back. When you made a mistake, there's no chance to correct it. So maybe after 2-3 months, you get the silicon and then it works or it doesn't. So the point of tape out is something that is, let's say, when you, same thing as if you start a rocket and with your satellite on it, and if it doesn't work, then basically you lost a lot of work, a lot of money. So that's why tape out is a term which is not just an action, it's also something very, it's a project milestone and it's very scary for the people involved in there. They usually have a deadline when to deliver that thing, and before tape out, a week before tape out is always like working night shifts, doing simulations, iterations, just to make sure that everything is perfect. So that's tape out. I mean, and eventually tape out means producing GDS file and sending it somewhere by FTP or whatever. Okay, that's about GDS. Okay, we went through this. It's just a copy of what I basically told. Okay, then let's go further. So we have done boxes, which are fairly simple, but it's very difficult to do layout just with boxes. I mean, you can basically. Who knows Magic? Magic does only have boxes.
Yeah.
Yeah, but okay, well, I mean, it's you can do so if you confine yourself to rectangular layout, which is also called Manhattan style, then you can basically compose everything from boxes, but it's not very convenient. So there are other objects, and specifically the path is an interesting one. Let's go here. The path is here. So this is the tool for paths. When you use paths, okay, a path is actually a line with a certain width. So it's typically used for wires. For example, you start from one point and you draw a wire to some other point. Paths and cadence paths are very, as they're used for wires, you have some support for auto-routing, routing. You can change to a different layer using wires and so on. Unfortunately, the KLayout is not that luxury, or not that luxurious. But you can draw a path, of course, but you have to set the wire yourself, leading to a next layer. That's something maybe to come. As I said, a path is a line with a width. So of course you need to specify the width. So let's take 1 micrometer. For example, you specify the width below here. And with that, I can start drawing the wire. So I click here at one point, the initial point. I click to the next one. I click to the next one, and so on. So I draw a path. Typically, these paths are supposed to be rectangular. That is not necessarily always the case, but for all we do in typical CMOS technologies, shapes are supposed to be rectangular. So you have seen I had a little trouble to, let's say, make it horizontal here. You can simplify that by clicking Shift, by holding Shift. If you hold Shift, then the movement will be the movement will be confined to vertical and horizontal only. So that makes it much easier to create a path which is, let's say, rectangular only. When you finish the path, you double click. So I forgot to mention this. You double click to finish the path. You can also hit Control. Control will also allow you 45-degree angles for paths. So then you can create something like that here. There's one thing I need to say about 45-degree angles. They are usually forbidden in CMOS technologies, even though they look nice, but they only create grid snap issues and things like that. So typically you are in technologies like maybe Skywater, I'm not sure, but more advanced nodes, you never can do 45-degree angles. You only can do rectangular or horizontal, vertical only Manhattan structures. There is also here some tab. You can actually enlarge this somewhat. You can, if this window is, you can also move it somewhere else if you want. But I would prefer to leave it here, otherwise I don't find it. Okay, so the basic editing, you can specify some options here, and what I actually did is I used Shift, and by using Shift I override these global settings, but I can configure that to be always Manhattan. So now I don't need to press Shift, I will also always have rectangular paths. So if you don't want to press Shift yourself all the time, then you just configure here. So Manhattan only, and then you can eventually draw these layouts only in Manhattan style. So, well, that's about paths. Paths have a few nice options. Okay, now you see I double click this path, and then it will bring up Path Properties dialog. And there you can edit the properties of your path or of any object. This is pretty generic, it's not just the path. And a path has a couple of attributes I can change. For example, if I use the extension type square, you will see here, now it has, so the first point is not actually the outline or the beginning of the path, but instead the path extends a little backwards. You can imagine the path being made of a pen or using a pen, which is a square thing. Yeah. So now the path extends a bit backward. That's typically easier if you place then a via on the path end, for example. Then you already have the landing pad defined. There's also one thing which is a round-ended path. That's an ancient GDS feature that comes from times when technologies were not, where you were using apertures, so photo plotters to make your masks, and these apertures were usually round things. But today we don't use these paths any longer. They are still there. And they are still valid GDS features, but well, if you look at modern technologies on silicon, these ends of lines will always come out as wall features. So there's no need to actually do paths like that. And then there's a variable extension thing I wanted to show you. So there I can actually specify any number or number for the extension, and the extension is this stretch or this extent here. I can configure the first extent, so the beginning of the path and the end of the path. Well, that's actually all I wanted to show you here. I pressed cancel now, so it brings me back to the original path. If I would have pushed OK, then it would have these changes would have persisted. Then, while we do paths, I can show you the partial edit feature. So if you want to change the path, so you made a mistake, you want to shift it somewhere else, then you can essentially edit just a point. Oh, it's quite difficult to see, I'm afraid. So this is partial editing mode, and when I point to the first point here with the mouse, you see this segment is highlighted, the first segment. It's a bit difficult to see. But now if I click there, I can change the first point. Yeah. You see, while I do so, the path loses its Manhattan property. But what I can do is I can also shift. Yeah, shift will only move the point in vertically and horizontally only, which will still make the path kind of skewed. But what I can do is I can also shift the whole segment. So like if I point here, I click, and then I'm moving the whole segment. So it stays rectangular. And I can, for example, now align it. I mean, that really doesn't necessarily make sense, but now I have aligned it with the bottom part. And I can also shift this segment, and I can also select segments here by pressing the left mouse button, dragging a rectangle, and now I have selected everything that is inside this selection box. And now if I shift it, I will only shift the selected parts. In Cadence, this is stretch mode, if you know it maybe. This is quite similar. And it basically works more or less the same way. In Cadence, there is also a way to specify a shift by a certain amount. This is also available here. So if you go to Edit Selection, Move By, then I can eventually specify the amount by which I want to shift. Okay. I don't know. What did I do? Okay, let's go back to partial. Yeah, I shouldn't do so while I'm editing. Okay, now I have selected parts here, and now I say again, edit selection, move by, and now I move by. Oh, sorry. Now I move by 1 micrometer in X direction, and you see the selection has moved by 1 micrometer to the right in this case. Okay, so any questions? Can you follow that? So, okay.
How you can? I've heard that in some designs they use multiple metal layers to make a root.
Yeah.
How can you do that?
Okay. Imagine we have 3 layers here. Yeah? One is, for example, the metal 1. So let's pretend this is metal 1, let's pretend this is the via connecting both metals. So via is typically the hole where you fill in metal. And let's say this is the second metal. Okay, then I would basically create a connection like first drawing something on metal 1. So let's do so. Then I'm here, then I want to switch to the second metal. Then I would select the via layer. Maybe let's take a smaller grid. Okay, oh, it's good enough, I guess. Then the via is something like that. So it's typically a square. This is not a square. Let's use this partially editing to correct it. So now I think it's a square. And then I switch over to the next layer. And now let's take the square end. So I can select the center of the via, and then I'll continue on a different metal layer. Does it look nice? I think you can see what I mean. So this is typically how you do a connection. Yeah. So the red thing now is the hole, forms the hole where you put in metal to connect upper and lower metal. Typically, you have design rules. So you cannot draw any kind of via, but typically you have a very specific size you can draw. And maybe it's like 100 by 100 nanometer, something like that. I think in Skywater it's like 150. So you draw a single rectangle or a single square actually to form this via. And of course the metal wires also have design rules. So you cannot go below a certain width. Often you can even not go above a certain width. So typically there's a standard width you're going to use for routing, for metal layers. And because these things are fixed, so that the dimensions are fixed, in real design environments, you usually don't draw every via yourself, but you have a cell. So we'll come to this later maybe, which places a single via between the metals. And very often you also try not to set a single via, but you try to set a pair of vias because this is a matter of yield. I mean, there's a certain likelihood that the via might fail. This is very low, of course, because the manufacturing process is supposed to make sure that everything works as expected. But there's a small likelihood, let's say 1 in a billion or even much lower, of vias to fail. But since you have so many vias on a huge layout, you try to reduce the risk of such a fail, because that would eventually lead to an open, so missing connection, and make your chip fail. And in order to reduce the risk, you place a double via, at least in places where it's critical or where you know that there's a certain manufacturing risk. So then this would look like, let me show you how to insert points. When I want to insert points on the path, I double click here. I use partially mode and I double click. Now I have created another point. And now I can change this one. Now I can move this one up. And yeah, let's adjust this a bit. So and now.
Double click. Double click.
First, I double clicked here. I just took this opportunity to show you some more features. I wanted to actually change the path so it goes like that. Because what I want to do is I want to create a new via here to show you this this feature, like that. So that's how a double via looks like, and the likelihood of such a via to fail is pretty low.
Double clicking opens object properties.
You have to be in partial mode.
Oh, okay.
Yeah, partial. So select partial mode first.
And then double click. Okay, that makes sense. Okay.
Okay. Now we have a double via, and so this I just hit Control Z, which is undo, like in every project, like in every program. I wanted also to show you how to duplicate this feature. So now I selected the via. I went to select mode. I I was drawing a rectangle here with the left mouse button. And now, of course, I can do Control-C, Control-V, like you do in Word or whatever project. Now I have duplicated this sphere, and now I'm going to use Move Mode. So I switch to Move Mode. I click here once. I shift that, and I click a second time. Again, 2 clicks, not clicking and dragging. Again, clicking once, clicking twice. Now I have moved the copy I made.
Oh, you made a copy?
Control Z, Control C, Control Z. Like copy paste. If you want, you can try yourself. So I have selected this rectangle by going to select mode and using Shift and drag to drag a rectangle and select everything that's inside. And then I used Control C, Control Z to duplicate it and move to shift it to the new position. And now I've created a nice double view. So in real design systems, you usually have via cells doing that for you. So you have a cell, a piece cell, parameterizable cell that you can configure to generate 2 vias instead of a single one. And then it will produce something like that for you. And usually these via cells also come with lower and bottom metal. So you don't have actually to draw the metal exactly how it needs to be, but you just place this via cell, and this makes sure that the metal overlaps are conforming to the design rules and so on. So metal is usually supposed to overlap a little, or at least be as large as the via cell, as the via shape, in order to allow for misalignments during the manufacturing process. Okay, it's again a lot for just discussing paths. Any questions so far?
Is there a way to, like, when you create a path, like you click and you click, is there a way to undo just the last click?
It depends which version you're using, because you can, I think you can just press delete, so the backspace button. So the let's try, but it's a feature that's not there since long, so I'm not sure.
Oh yeah, backspace.
Backspace works though. Okay. Okay, yeah, it does. I didn't remember, to be honest. Okay. Yeah, I think the whole thing is more or less like PowerPoint, right? So, but it's, I mean, it has layers, it has, we will see cells, it has, yeah, colors, yeah, like PowerPoint. But you cannot color every object individually, for example. So, okay. No, I didn't want to exit. So let's go back to the presentation. Okay, so this is actually just what I explained to you, minus all these additional things like copy paste. Well, I think this is more or less also what I showed you. Properties dialog, we have change layers there. Okay, delete. I mean, if you want to delete something, just select it, click on it once, or drag a selection box and then hit delete. Okay, this we already went through. Okay, maybe this is like a little parenthesis I can open here. So if we speak about layers, who of you worked with real PDK so far? So with like a Cadence PDK? I think most of you did, or some of you did. When you open Cadence and you have a layer list, which in Cadence is on the left side, here it's on the right side, usually you have drawing layers, and drawing layers mean something. So a drawing layer means, for example, a metal layer. So whenever you draw something, you expect that metal shape will happen to be where you have drawn it. like what we did exactly now. So we have drawn a wire, we expect metal to be produced here. So there are a bunch of layers, and this typically comes with the PDK. So the technology setup you get from your vendor, from your provider, from your manufacturer, lists a lot of layers. Typically, maybe there are 100 layers or even more. And there are physical layers, there are marker layers, which do not have a physical meaning, but they, for example, you could mark a certain device by drawing a rectangle around it. So this simplifies the processing of the layers later in terms of detecting devices, things like that for verification. So you have a lot of layers. These layers come with some styling, so some color, some fill shape, and so on. And most of these layers, or many of these layers, correspond to some material features, like a certain material or a certain material property, like, for example, implant layers. They mean whenever you have drawn a shape layer, the substrate material gets, for example, N doped or P doped. And so layers have a meaning. And what I did so far is not to use a specific meaning, we were just using numbers. And but usually you get something like a technology kit. And this technology kit specifies these layers in terms of their meaning and in terms of their GDS layer and data type. And KLayout uses these uses layer property files. So that's KLayout specific files which specify what layers are there, how they are styled, and also gives these layers a name, which is pretty important because you don't want to remember 100 GDS layers. You want to see that the layer is a metal 1 drawing layer, for example. And here, for example, we have this is a simple example. I once created a kind of technology setup, so a hypothetical technology, which is on GitHub, which comes with a few layouts and which also comes with a few, which such a layer properties file. So this is pretty, well, it's not a real technology, but in reality, it probably also looks like that, at least for classical planar CMOS nodes, like Skywater node. This is an example for an inverter. This is pretty much like you know from the textbooks. When you have a textbook about VLSI design or layout, you will always find pictures like that. And that's the schematic. So you have an inverter has a P and an N device. And from the layout, it looks like the left one. So this is the N device. So that's the gate, source and drain. And you have the P device, and the P device sits in a well, N well. So you can manufacture a P device there. And then you have a couple of implant layers, and the cross section then looks like that. So when I do a cross section on this red line here, you get something like this, and this is a classical planar CMOS device, like you will find in every textbook. And in order to get this device, you usually draw, it's a bit hard to see, you draw a well area, which gives you the base implant. So provided you have a P substrate, you first have to change it to N for the P devices, and then you implant P plus. Then you first you manufacture the gate oxide and the poly for the gate, and then you implant P plus, which forms the. I do a lot more basically, but okay, that's the short version. Then you have P plus forming the source and drain, and then you put contacts on top of that, so metal, so holes in the oxide where the metal is filled in, and this then touches down to the source and drain area, and it will make the contacts to the metal above. And the connections here you see in this schematic. Here we have a VDD, so the power supply line, the positive power supply, it goes down here. So this is the source connection for the P device. Here that's poly, which forms the gates. usually you have a polyline going straight through. This is the gate net here. It goes down to the N device. And then you have a connection between the drains of the N and P device, and this forms the output. And then you also have a VSS pin connecting to the source of the N device. In addition, you need taps, so substrate contacts, so things which connect down to the N well, because the N well is supposed to be on VDD level, and the substrate is supposed to be on VSS level. So you have to kind of connect substrate and N well in addition. This is missing here. Usually you add this once you have built a larger device, a larger macro. You add filler cells or spacer cells or special tap cells between. This is typically a task of a digital flow then, to make sure that the N well areas are well connected to the VDD. And this is important because if you don't do so, you will get latch-up effects, and your device will probably fail, or it will suddenly go into latch-up and then be damaged. Is this all new to you, or do you? I mean, this is essentially what is. I'm just stating textbook knowledge here. So I think, well, you can read it. Yeah.
I was just wondering, so how do you put in the, say, Skywater layer definitions into?
Okay. Yeah, this you see here, this link specifies the GDS file, and in this project, let's just go to GitHub. This is, as I said, this is just an example project. Come on. Okay, it finds it. Okay, this is a project I published on GitHub. It was intended to be used as a kind of playground for doing these exactly things we're doing here. That was at a time where there was no Skywater. You will find similar setups for Skywater as well. And even now there's a 180 nanometer PDK that recently has been published, which also comes with these kind of files. This is just one thing you can play with. If you want to, okay, let's just try using them. So here I have provided a tech.lyp. This is the file which styles all the layers for this particular dummy technology, or playground technology. And this file you can download if you like. I'll show you a trick. You don't even need to download it. There's the KLayout window. Okay. Yeah. I need to. So, okay. What you can do, I have my KLayout window here, and I go to this file, and this file has a raw button here, and this is a link I can drag and drop to the KLayout window, and then it will download this file and use it as the layer properties file. So what happened here? Okay, that was a kind of nonsense we did before, but now it will load the layer colors. It will also load layer definitions for other layers, which I didn't define so far. And the usual way is not to drag and drop files from websites, but the usual way is to install a package. KLayout has a concept of technology setups where you have predefined layer property files and also other things. And usually you install this package from somewhere, like maybe it's on GitHub or whatever. And then you have a way of assigning a specific technology to a layout you are drawing. So this is kind of, well, it's a bit advanced how to do this, so I would like not to cover that here, but if you like to know how this works, I can show you. Then you don't need to download, you don't need to configure things yourself, it all comes in one package. But you see here, now I have installed this layer property file, and okay, let's first clean this thing because it does not make a lot of sense. So, but here you see I have a metal 1 layer, for example, and if we go again into this path mode and I start drawing a path, I can select a metal 1 from here. I can select metal 2. Here there's the via. So let's draw a box. Okay, it's not like that. I can switch to metal 2. I'd like continue like that. Yeah. So and now I see, you see there are names now. So these layers have names. That these layer names are not saved into GDS. So if you save a GDS and you load it and someone else loads it, don't expect these layer names to be there because GDS only have numbers, has numbers. And but this other person you give the GDS to could also load this layer property file. And then again, he will see the layer names and knows what this layer means. Otherwise, he would just see 9 and 11, and then, I mean, if you have 100 layers, then you have to have a document, you need to look up all the layers, so it's quite tedious. It's very convenient to work with these layer property files, and the layer property files basically contain everything that is in this right side column here. So everything you have set up is stored in these layer property files. And these layer properties are pretty mighty in terms of configuration. So, for example, you can create tabs. So you can duplicate these layer property files, or not the files, the content of this layer list above. So you can create different views for different purposes, like people seeing only certain layers, or like people having other colors, or like setups for white background and the second one for background, like black background and things like that. You can also group layers and so on. So this is quite a powerful concept here. But that's a topic on its own. Okay, so and basically, when you have a technology setup, when you have a real technology, real PDK, it will always come with a kind of layer properties file. So you don't have to know these numbers, you don't have to look them up. And a technology setup typically also comes with DRC tags, for example, that you can execute to check whether your layout is conforming to the design rules. Do you have, when I talk about design rules, is this something new to you, or who knows what a design rule is? You know?
Yes.
Okay. Yeah. I mean, design rules are basically the law you have to follow to make your chips work. So, I mean, a process cannot go below a certain dimension, for example, just because the lithography will not allow you to go below a certain line width, for example. And it has to be made sure that your layout is conforming to these design rules. Otherwise, the process will simply not be able to produce a wire where you want to have one. And that's why it's important to comply to design rules, and design rules are checked with a tool that is called DRC, design rule check. And you typically run it. Once you have done your layout, you will see there are violations or errors, and you have to fix these errors before you tape out. Otherwise, your chip won't work. I mean, a modern technology, you can easily have like 4 or 5 or even more 1,000 design rules. Many specific ones only for certain purposes, but also very generic ones. I mean, I don't know, Skywater has very few, so like 100 roughly. I don't know, like about 100. But the Skywater PDK is not fully evolved. in my perception. So it's only a partial PDK. I think they have added only the absolutely necessary design rules. But when you design in advanced nodes, 20 nanometer or something like that, or even FinFET, I think you have, I don't know if it's even more than 5,000 different design rules you have to comply with. And you need a tool to check this. You cannot do it manually. Okay. So. This was how you use it. Okay, so if you, like I told you, if you want to use these layer property files, typically you use some kind of technology setup, or you can also use them from command line. If you have downloaded this file, you just run KLayout with the file you want to edit and -L to specify the layer property files. Well, as I said, typically we will work later with technology setups. Okay, then another important point is, so how do you feel basically, because it's almost an hour. I mean, this is actually the last point about editing layout. I think I will finish within the first hour, and then we can make a break, and then we can go to, let's say, how to script things. Is this already boring, or?
No, it's okay.
Very good. Okay. Okay, very good. Yeah, I mean, I try to feed in other things, not just how you use the tool. So I hope you will learn something that is not necessarily in every textbook. Okay, so cells. You will see this panel here. Yeah? It says cells. What is a cell? A cell is essentially something that is a group of shapes. Like you can think of PowerPoint when you select something and then you group it, or any other drawing tool. Then you have something that moves around, and you don't move every single shape, but instead you move the whole thing. Yeah. And you can basically think of a cell of something similar. In VLSI design, a cell has a slightly more advanced meaning. A cell is typically something that is a building block. It can be a device, it can be a unit, a macro, an ADC, or even the top level of your chip is a cell. Here I do not have multiple cells, I have a single one. And the single cell is called top. The reason why it's called top, let's see if, okay, let's just show you the thing. The reason why it's called top is that you have cells that you use in other cells. So let's create one. So in order to create a cell, I go to edit cell and say new cell. Yeah. So, and the program will ask you two things. The first is the cell name, and the window size is just the size of the window it will show initially. The most important one is the name of the cell. Let's call it unit. Just to say this is some unit I want to use. Do you have a question? That's okay. Like before, I mentioned these via cells, right? So I can now try to do something like generating such a via. I go to metal 1. I place a first metal. I go to via 1. I place the via rectangle. I go to metal 2. Let's place a somewhat bigger rectangle. So I have 3 shapes now, 3 boxes. One on metal 1, one on via, one on metal 2. Yes?
But I may have missed it or something, but the grid snapping for drawing things is very, very fine for me.
Okay, then did you configure some grids here?
Oh, okay.
Oh, let's see how it looks on the screen.
Yeah, there's only like very fine choices.
Oh,
You
okay.
can do a big zoom.
No, you can go to File Setup. File Setup, and there's grid. Sorry, default grids. Default grids. And then you can
okay.
add some more, so like comma, so 1, comma 2, 1, or something like that. And then you should see the others, and you can choose course.
Okay, great. Thanks.
Okay. Yeah, it's much more convenient to work with course grids. This is, by the way, one of the best features that I mean, no PowerPoint manages to work with grids properly. Inkscape does to some extent, but I mean, if you want to have technical drawings, they should be on a grid. So PowerPoint is the worst tool to do technical drawings, by the way. Okay, so we do have this flicker effect. It's not too annoying. Anyway, I have created now a cell. Yeah, let's not call it unit because it's a via eventually. Let's rename it. So I click on the cell, right mouse button, and say rename cell, and let's call it via. VIA. So now I have a thing which is called via, and a thing which consists of 3 rectangles. And you see I have drawn these rectangles in a symmetrical fashion around this origin. So here is the 0 coordinate. By the way, you can see below here where the coordinate of the mouse cursor is. So here's the 0, 0 coordinate. Here is -.5, +.5 here, and so on. The reason why I have drawn it symmetrically is that the center, so the origin of a cell, plays a certain role. This is specifically the position where you place a cell later. So when I put a cell somewhere, I always specify the location of the origin of the cell. This is important when you code layout later. And in order to place this cell, there actually one very convenient way is to just okay, sorry, I didn't show you how to switch. Okay, to switch to a different cell, you use the middle mouse button. So you click here, I click here to switch to the via cell. I click with the middle mouse button here to switch to the top cell. Instead of middle mouse button, you can also use right mouse button and use show as new top. Yeah. So this will also change to the other cell. So this is how I can switch between the cells. Now I'm back to the top cell, which I originally created. And now I want to use this via cell. And a very simple way of doing so is to take this via and drag it over here. Yeah? Okay. So first you drag it, then you release the mouse button, and then you place it somewhere. And I can place it like many times. Yeah? If I want. I mean, let's place it here. So, and you see, now it only shows a box with via printed in. And that is a matter of hierarchy settings, because the cells form a level of hierarchy. So I have a parent cell and a child cell now. I have a top cell and a child cell. The child cell is the cell used inside a cell. That's the naming, the convention, the naming which is typically used in this context. I have basically a 2-level hierarchy this way. So I have a top cell and I have a bottom cell. And you see here, I press escape now to leave this mode, this instance placement mode. You see here that setting. It means as of now, I only show the first level of hierarchy because the value is 1. I can increase this level. And if I increase it, I also show the content of, I show up down to the second level of hierarchy, and now I also see the content of the cell. Right? In Cadence, this is quite similar. I think you can just press 0, 1, 2, 3 to enable certain hierarchy levels, or Shift F. In my Cadence version, I'm using it Shift F to display the full level of hierarchy. In KLayout, it's by default it's Shift star. So there's also minus and plus. You can switch the levels, and if you hit star, so Shift and plus it's in my case the German keyboard, then you will show all hierarchy levels, which means you will show the content of all cells down to the very bottom ones. So, and now you see I have placed this VIA cell in various locations, and I have basically duplicated this layout here. And this duplication doesn't happen in terms of data. So in data-wise, I have 4 instances only. So I have basically 4 locations and the name of the cell. And the cell can be huge. It can be a full CPU core, for example. Right? And when I place the CPU core 8 times, I have a multi-core CPU. Okay, it's not that easy in reality, but I can basically multiply a layout without actually having to specify a lot of data. Right? So it's a single item. It's just a coordinate and a name, and I can eventually instantiate billions of shapes at once. Right? In this case, it's only 3 rectangles, so it's not that spectacular, but well, it's the way it works. And I need to show you something very important here. When I now edit this cell, so I can select a shape here, for example, and I can move it. So I shift it somewhere, and now you see the shape has moved in all these cases. Wherever I have placed the cell, the shape shifts the same way. So this means the cell is still kind of alive. So it's not copied in terms of being an independent copy, but all these 4 places where I've placed this VIA cell share the same content. And if I change it, it will change in all these places. Yeah. And that is something that is both interesting because it means I have only to touch a single place and it will automatically change everywhere I need it. On the other hand, it's pretty dangerous because when I change something somewhere and I have just selected the shape, right? I don't know that I'm inside the cell. So imagine I have, let's go back. Imagine I have zoomed in, yeah, and moved the shape somewhere. I don't see that all these other places have changed too. So this is something that is basically risky because in my view here, I have changed just one location, but in fact it changed everywhere else. And that's why usually when you edit, you don't work in this mode. There's another mode. Okay, let's undo. There's another mode, which is in the view menu, which is called select top level only, top level objects. I mean, for Cadence users, this feature, so the default mode is called edit in place in Cadence. So while the normal mode is that one, if I select this one, so now you see this is checked. If I select this one, I cannot select something inside the cell. So I cannot select this single rectangle, but I can just select the whole cell or this whole instance. And if I move it, I just move the cell as a whole. So I can not go into the cell, modify it while risking to change all other places. So I'm only able to change the cell position, cell location, and not what's inside the cell. In order to change what's inside the cell, I need to either go to the cell, or there is something that is called descent. In Cadence, it's called, also called descent, I don't know. I know it has Shift X in my case. Okay, anyway, so I can click on this cell, and then I can use display descent or Control D. And now I am inside this cell. This one, yeah, and you see everything else is kind of reduced in brightness. So which means that here is where I'm currently editing. And now I can edit, I can move this, and you see all the other instances move, but now I have explicitly entered the cell. Now I know I'm somewhere else, and I can change things here, but then I can go back by using the opposite. Display ascend, and then I'm brought back to top level, and now I cannot select this shape anymore inside the cell. And this is what comes with the select top level objects mode. And this is pretty well for people doing real layout. This is pretty important to observe that this mode is kind of safer to use and more and closer to virtuoso, if you're used to that. Okay. Any questions here? Regarding that?
So this mode is different than the normal editing mode, right? Because it's only let you select in the hierarchy that you are.
Exactly. So what we did so far was not affected by this mode because we were only editing in the top cell, right? So we were not doing anything in the bottom cell.
There's a way in that we can like modify an instance, but create another cell that it's like a replication of the others, but independent, so we can have specific
yes
features in that.
Yeah, it's kind of special feature, but you can actually do so. So I will show you. You select this instance, and then there's something that is called in edit selection make cell variants.
Make cell variants.
Yes. Okay, if I use this, you will see now we have two VIA cells. One is called VIA, the other is called VIA $1. And let me reduce the hierarchy level. So you see this is VIA $1 and this is VIA, right? So the one I have selected now becomes a different cell. Yeah? And now if I change this cell, the other ones are not affected by this.
You just renamed it to VIA $1.
What do you mean?
How exactly did that happen?
Okay, let's go back. So the way I did it is I selected this thing, this instance I want to change. It's a bit difficult to see here, but this is the one I selected because the selection color is also white. But I just clicked here, and then I went to selection, make cell variants, and then this got changed to a new cell. So I have two cells, and the ones I have selected now become special cells. And when I edit these, the others will stay unaffected. Well, honestly, I don't know whether this is super important here because usually you don't want cells to kind of branch, right? If you have something like a device or something, some unit, you want to reuse this unit as many times as possible. So you usually don't create variants so much if you absolutely need to.
So then $sign is off limits for naming your pieces?
No, it's not off limits. I mean, it's an allowed character. You can also rename it. If you don't like the $, then you just rename that V2.
It's just a default thing.
It's a proposal the program makes, but it doesn't need to be $. Just generated by the program. Okay, and about hierarchy, now we can basically go on. So we can create cells of cells, or we can create with cells with subcells. We can place these cells again in others. So you can have a hierarchy which goes to many levels. So if you have a typical memory design that can easily have 10, 15, 20 levels of hierarchy. Yeah, 20 maybe, that's a bit exaggerated, but like when you go down into functional blocks and for memories, it's typically nested. They combine pairs of rows into bigger pairs and things like that. So memories are typically like 10, 15 levels of hierarchy, but they are also quite complex already. So cells allow you to basically group things, to multiply things. So it's you can in a few bytes you can essentially create a lot of shapes. And what I also wanted to show you that if I double click, I get the properties again. And there's something that is called an array instance, which is quite interesting.
Oh.
Yeah, this is okay. Okay, let's. How is this work? So let's do that. Okay. So you see, now I have generated a bunch of cells here in a single object, and it's 100 by 100, and I have two vectors. So one specifying the stretch in one axis and one specifying the stretch in a different axis. And these vectors, they should be, well, they can be any vectors, right? But not every tool will accept every kind of array. So I would recommend using X and Y only. So one vector being vertical and the other being horizontal. And that was the original intention of this feature in GDS. So it was intended to create rows and columns, so a real array. But I mean, it's not impossible to do something else. Like if I use a different vector here, so like that, you know, then one vector becomes that one. So 1, 2, which means 1 in X, 2 in Y direction. And then you see the propagation axis here is kind of slanted. This is possible, but I had reports of people having trouble then sending such GDS to mask makers because they sometimes don't like it if they have a very old tool set. Modern tools properly read these kind of arrays. But that's why there's a warning here. You should be serious what you do here. On the other hand, many tools actually generate such arrays already. And these array instances, they are ways of generating billions of shapes with just a single object. And as you can imagine, they are used frequently in memory designs, for example, if you want to generate memory arrays. And that's why, in fact, memory arrays are basically very compact things in terms of data size. I mean, there's a funny story. So I was working, so like 2005 to 10, I was working for a DRAM company in Munich, so Qimonda, and their core IP was the DRAM memory core block, and it was like, I don't know, 116 megabit block, which was the building block. And of course, it was made of arrays. Right? And the DRAM core feature is like, well, it consists of the memory cells, but also the sense arms and column drivers and so on. And the whole thing, when you streamed it out to GDS, that was 23 kilobyte of data. So the core IP of this company was 23 kilobytes of data. So it was like, you know, all the engineering they did all went into this core feature, and it was just 23 kilobytes. But this company is dead since 2010. Not because of that. Okay. Well, okay, then let me quickly go through the slides. Then I think we're done with the first part. Okay. So that's what I basically explained. So cells form groups. Basically, they're used for functional entities typically. Typically, they also act as a kind of as a counterpart to schematic. blocks. So if you have like a device, that's typically one cell. If you have a gate, that's also a different type of cell. If you have a macro, that's also a cell. And so typically when you do LVS, so layout versus schematic, these tools typically check cells versus cells. So cells can be graphical aids to group things, but they also have a functional meaning, typically, like being a gate or being a device. Okay, this is how you do it, just what I showed you. This is a cell. So these cells logically form a graph. So you have a top cell, you have child cells. In this case, the B cell is used inside A and inside the top cell directly. So this is perfectly normal. And on the right, you see the terminology that we usually use. So the top cell is the cell which doesn't have parents. You can even have multiple top cells in GDS. That's not something every mask maker will accept, but you can have them if you like to provide multiple blocks into a single GDS cell, single GDS file. Like for libraries, for example, gate cells, different gates you can put into GDS and give each gate a different top cell. So the top cell is the parent of A and B. A is also the parent of B, as you see here. A is a child cell of top. B is a leaf cell, which means it doesn't have children itself. That's the terminology here. Yeah. And as a hint from my side, so if you deliver a layout to some mask maker, make sure it has a single top cell, because it happened actually that they took the wrong one and you have the wrong version of your design on the mask. And if that one happens to be non-functional, then you're in a lot of trouble.